Okay, this is FRQ 5. Two 15-minute problems in this particular video, so that'd be a total of 30 minutes if you were to time yourself. If you are planning to take the AP test this year and you have not yet timed yourself on your FRQs, you really should be doing that. You'll have a few more FRQs still on which you can practice, or you could always go back and redo some of the others. But make sure you are timing yourself, especially for those of you who are considering possibly using notes in conjunction with your AP test. You want to make sure you realize how much time looking through your notes takes, and how vital it is that we either have our notes organized very well, or are, ideally speaking, learning to not use them, because you really can't afford to look at your notes constantly if you're hoping to get into your 3, 4, 5 range. Now, that being said, there is a very high likelihood you need to prepare yourself for this fact that you won't finish all of your FRQs in the time given. That's a reality every year. College Board has reiterated that this year, that you need to make sure you're prepared for the fact that you might not finish, and that doesn't keep you from getting a 4 or a 5 or a 3, right? Because you don't have to get 100% to get a 5, right? We've talked about different percentages over the years to keep in mind, or over this school year to keep in mind. And so you can't let that panic you, but you need to time yourself so you start to experience what that's like to potentially still be working on Part D as the 15 minutes ends. Because that might be what you experience on the AP test in 2 weeks or so. So again, time yourself, make sure you are starting to get that experience, starting to be realistic with yourself. Okay, here we go. FRQ 5, first one was a non-calculator from 2017. It says, at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, so we've got an initial position there. Again, I've talked about this many times, but for me, anytime I see that initial position, I always initially write down some sort of desired position formula. Sometimes it serves a purpose, sometimes it doesn't. In this particular one, we're actually not going to end up using that, but I'm still going to write it down because, again, that's what my brain's starting to think about, is that desired position formula. Okay? The internal temperature of the potato is greater than 27 degrees. So let me go ahead and write that. Temperature will always be greater than 27 for all times t greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h. So h represents temperature, t represents time. So I want to make sure I'm careful to not use t for temperature, because t is minutes here, time. That satisfies the differential equation, dH dt equals -1/4 h minus 27. I don't myself love different variables, and so I'm going to go ahead and write y equals h, x equals t, because now I can call this dy dx equals -1/4 y minus 27, just for myself, okay? And then again, they reiterate that starting point, which is that at t equals 0, my temperature is 91, which is what they wrote up here. At t equals 0, my temperature is 91. Okay, so part A says, write the equation for the line tangent. So this has shown up quite a few times at this point. I think you'll have at least one more before the AP test where you'll see that instruction. And so the minute you see that, you're doing some sort of equation. So we're thinking y minus y1 equals m times x minus x1 to the graph at t or x, right? Because I called my t x. So x equals 0. So we can go ahead and plug that piece in. My x is going to be 0 back here. And then use that equation to approximate the internal temperature of the potato at time t equals 3. Okay? So, x equals 0, what then would be my y? When x equals 0, my y is 91. And then what would be my slope? Remember, slope comes from your derivative. That's what a derivative is. It is a rate of change. It is it's a slope. And so this here represents my slope. Again, one more time, as we've talked about in different videos, make sure you are not putting this derivative here. This represents the slope at every possible point. We're looking for the one very particular one at, in this case, x equals 0, y equals 91. So at this point here, 0, 91. So I want to make sure I've plugged that in. So in this case, it's plugging 91 into that y spot. And then you have a choice to make. Remember, you don't have to simplify anything. So you could actually plug into your slope spot here negative 1/4 times 91 minus 27. And you could plug that entire thing negative, let me write that down, negative 1/4 91 minus 27. You could put that entire thing in here and call it good. You'd have your equation at the tangent line, so you wouldn't have to go any further. Or you could simplify this if you want to. Now it is a non-calculator, and you don't have to simplify, so I would say that's a waste of time. But if you did simplify, you would get 64 times negative 1/4, which is negative 16. Okay, so either one works. I myself would recommend putting the negative 1/4 91 minus 27 into that m spot and then calling it good. Okay? And the last things, we've also done this one several times, which is use your equation to approximate something. In this case, it's what happens at t equals 3. So we're going to plug 3 in here, so negative 16 times 3 minus 0, and make sure you add this 91 over. And again, I would stop there. I wouldn't go any further. You don't have to simplify, right? But if you did, this would be, let's see, negative 48 plus 91, which is 43. So yeah, you could simplify if you wanted to, but again, kind of a waste of time. Okay? This one was worth 3 points. I have a red pen here. So 3 possible points. 1 for your slope, knowing to plug in your value to your derivative. 1 for your equation. And so if you had maybe accidentally, I don't know, if you had made an error, so maybe you plugged in 91 and simplified wrong, or I don't know, something like that. Again, as long as you haven't oversimplified the problem. But if you've made an error in finding your slope, but you plugged your slope in here, you could still get your tangent line equation, again, as long as you haven't oversimplified. And then your last point was for your approximation, which again did not have to be 43. You could leave it unsimplified. Same thing, if you made an error up here, so then had the wrong equation, but you plugged into your wrong equation correctly, then you could still get your approximation point, again, as long as you haven't oversimplified. And as I've said through each of the videos, if you're sitting there looking at your work going, I don't know if this counts as oversimplifying, send me a picture, message me through Google Classroom, like whatever you prefer. I'm more than happy to check that for you if you would like. Okay? Okay, part B, we have use the second derivative to determine whether our answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. This year, ladies and gentlemen, it was interesting that a lot of, well, I shouldn't say a lot of people, but there were individuals I know who got to part B, read part B, and went, oh no, I don't know how to answer this one. I'm not sure what they're asking me to do, and so stopped. They didn't go on, which was a little bit unfortunate this year. And you need to make sure you watch that for yourself as you take your AP test, because remember, you're going to hit parts that are a little bit out there. The AP test is designed to push the boundaries of things, to kind of see what students are able to do, and to see that as AP students, do you persevere? Do you keep going, right? So you can't let maybe an oddball part of a problem throw you off. For individuals who this particular year got to part B, read it, went, oh no, I don't know what to do, and stopped, they missed out on a part C, which is very straightforward, because they didn't go on, they just stopped at part B, and unfortunately part B was only worth 1 point that year. 1 point. There were 5 points associated in part C. And so again, skip around on your FRQs. If you read one, you're like, I don't know. move on. See if there's another part that maybe you can tap into. Come back to part B afterwards, or whatever part it is you've hit on. But don't let it throw you, okay? So again, it was worth 1 point for your answer, which we'll show here in a bit, and then a reason, because it does say, oh, it doesn't actually say, but to determine whether it is, so we're going to give a reason for why we know. Okay, so second derivative here, so we need to find a second derivative. I don't currently have that. Okay, so we're going to go ahead and take our second derivative. Negative 1/4 is a coefficient, so I'm just going to let it hang out. Derivative of, I also could distribute it if I wanted to. Derivative of h is 1, and then dh dt, because I just took the derivative of an h. Derivative of 27 would be 0, or even if you had distributed the 1/4, you'd have 27/4, which still is a constant. Its derivative would still be 0, which is negative 1/4 dh dt is negative 1/4 times h minus 27. Negative 1/4 times negative 1/4 is 1/16. And it's possible that some years finding the second derivative would have been a point. It didn't happen to be this year, but I could see that potentially happening. In this particular case, like I said, it wasn't. This entire part was worth 1 point, which came from now being able to state, well, if this is my second derivative, do I know whether or not my tangent line approximation is an over approximation or an under approximation? And so we talked about this a couple of videos ago. I don't remember which one it was, but if you want me to find it and send it to you, send me a message. I'm more than happy to find it, even what minute mark we talked about it if you would like. But under an over approximation here is determined somewhat by concavity. I'm going to draw this in red off to the side because it's not really part of the problem here. But if you had a concave up function, right, which is a positive second derivative, then your tangent line approximation would be an under approximation because the tangent line would be below that graph. Versus if you had a concave down function, then its tangent line approximation would be an over approximation. When the second derivative is less than 0, it would be an over approximation because the tangent line would be above the function. Okay? And so in this case, what does this second derivative tell me? Am I concave up or concave down? Okay, well, this second derivative is positive. And we know that because 1/16 is a positive number, and h, which is our temperature, right, h, which is the internal temperature of the function, it is always greater than 27. So no matter what value I put here, because it's going to be bigger than 27, that will be a positive times a positive. And so my second derivative here is positive. My function, therefore, is concave up. And so therefore, my estimation is an underestimate, right? And so then you would say that. Underestimate because the second derivative is positive for all t greater than 0, making h a concave up function. Or something like that. Again, reasons can vary. If you wrote it a different way and you're like, I don't know, does this work? Send me a picture again, happy to check it. But this is how I wrote it. Okay? There's another way, I believe, in the rubric, if you also wanted to see a slightly different way of writing that information out. Okay? Okay, but again, 1 point for those who moved on, they would have seen that part C asks us for something we've done quite a few times at this point, initially back in 4.1, came back in Unit 5, came back again in our Unit 7 with our slope fields. It has shown up quite a few times in our FRQs here as we've practiced, because it says, for T less than 10, an alternate model for the internal temperature of the potato is G such that dg dt equals negative g minus 27 to the 2/3. Careful here, by the way, for those who like changing their variables, make sure you don't make gy. You've already made hy, so you would need to make g some other notation. Because I already changed my variables on part A, I'm going to go ahead and leave them alone on part C. That way I'm modeling it both ways. But I did want to make sure you heard that. If you are someone who likes changing your variables, that's great. Go ahead and do so. I do that myself. But make sure you don't use a variable that's already been used somewhere else in the problem. Whether you used it or the problem itself used it. Make sure you aren't accidentally double using the same variable, right? T could still be x, right? But G cannot be y. H was already y. Okay, so satisfies this equation. We have an initial condition again of g of 0 equals 91. Find an expression for g of t. Okay, so these are going to be very similar points to what we've used or what we've heard in the past. So step 1, separate the variables. You're going to get the g's on one side, the t's on the other. Okay, so I'm going to go ahead and divide this g minus 27 to the other side. Multiply the dt to the right. So we've got the g's on the left, the t's on the right. And then we are going to be integrating both sides. Now this guy here is g minus 27 to the negative 2/3. So that I can use power rule on it, adding 1 to the exponent, dividing by the new exponent. Back here, this is negative 1 that we are going to be integrating. Okay? So you had 1 point here for your separation of your variables. And then we're going to get 1 point from our antiderivatives. And unfortunately, you did have to get both antiderivatives right to be able to get this, this second point. But so adding 1 to the exponent, we would have g minus 27 to the 1/3. Divide by that new exponent. Negative 1 would just be negative t. And if you did get those antiderivatives correct, you got a point. If you got them wrong, same rule as always. If you didn't oversimplify the problem, you can continue to get the rest of the points that are part of this problem as long as you haven't oversimplified. And so again, and as long as you keep going correctly with your mistakes. Again, if you aren't sure how to assess that for yourself, send me a picture. Okay? At this point, we are going to need to plug in our point to solve for C and solve for G. As always, it's your choice what order you put this in. I myself am going to go ahead and plug in and solve for C first. I'm also in that process going to multiply by 3 instead of dividing by 1/3, just so you know. Okay? So G is 91. And t is 0, which gives me a real quick c that I have now solved for. Remember, you don't have to simplify anything. If you did simplify this, you would get 12. 64 cube root is 4 times 3 is 12. But you can leave it like that and you are good to go. Okay, and then plugging that back into our equation here, we have, again, I'm going to write it as 3g minus 27 to the 1/3 equals negative t, excuse me, plus 3 times 91 minus 27 to the 1/3. And then solving for g, we're going to divide that 3 over and cube both sides and add 27. Okay? So, writing out what I had. We're going to divide the 3 over, cube both sides to get rid of the cube root, and add the 27. And you've got your g of t. Okay, based on this model, what is the internal temperature of the potato at time t equals 3? So we're going to go ahead and find g of 3, which again, one more time. Actually, you're going to hear me say it a couple more times. Sorry, I know I'm a little bit of a broken record about it, but we have it drilled into ourselves for so long that we can't leave things unsimplified. We can't leave things unsimplified, and we're having to break ourselves of that habit to a certain extent. One more time for now. Make sure you don't simplify if you don't have to. There's no reason to simplify all that junk. It's a waste of time. You don't get any extra points, so leave it alone, right? If you did simplify, you would get, let's see, this was 12. 9 divided by 3 is 3, cubed 27 plus 27 is 54, so it would simplify to 54, but again, I wouldn't do that. Okay, that's where your last 3 points come from, is all of that work. They are 1 point for your solving for C, 1 point for solving for G, and then 1 point for your G of T and G of 3, your approximation here, okay? Okay, second 15-minute problem. We have from 2019 an FF prime F double prime graph. We are looking at a graph of F here. Always good to make sure you take note of that. The continuous function F is defined on the closed interval -6 to 5. The figure above shows a portion of that graph consisting of 2 line segments and a quarter of a circle centered at the point 5,3. So I can see my quarter circle here is upside down. Let me actually shade in that quarter circle with a pencil just so we can see what they're talking about. Because I remember this year some students, anyway, said that was a little bit hard to see. So I want to make sure that we see what they're talking about there. Okay? It is known that the point 3, when x equals 3, y is 3 minus the square root of 5, is on the graph of F. Okay? So part A. If the integral from -6 to 5 of f of x dx equals 7, find the value of the integral from -6 to -2 of f of x dx. Okay? Well, let's start here. The integral from -6 to 5 of f of x dx, which is equal to 7, is built up of the integral from -6 to -2, and then -2 the rest of the way to 5. Right? That's a 4.3 property is where that comes from. And so then we can solve for this integral from -6 to -2 of f of x dx by subtracting this integral behind that -6 to 5. And -6 to 5, remember, was 7. Right? Okay, and so then what is the integral from -2 to 5? Well, -2 to 5 is what's shown on our graph here. And so we can go ahead and calculate that integral, 7 minus. So -2 to 5 would start with this triangle right here, which is, I'm going to put all of this in kind of big parentheses, 1/2, base of 1, height of 1. And then this triangle here, which is negative because it's below the x-axis, so 1/2, base of 2, height of 1. We then have this triangle here, which is 1/2, base of 2. Oh, it's not base of 2. I'm sorry. This is only a base of 1.5. So 1.5, 3 halves there. Base of 1.5, again. Height of 3. And then this last piece is the one that I view as kind of the trickiest, because we don't really know how to find this area that's underneath this quarter circle here as the shape that it is. However, what we can do is find the area of this entire square, which is a 3 by 3 square, or 9, and we can subtract away that quarter circle, 1/4 for quarter, pi r squared. Radius here is 3. 3 squared is 9. And so if you take the square and subtract away the quarter circle, taking away that region, you'd have what was left under that piece. That last part in particular, I feel like, is the trickiest. Okay? And then you don't have to simplify. If you do want to simplify, you would get, oh goodness, 9 pi over 4 This would be 1/2 minus 3/4, which would be -1/4, plus 9/4, which would be 2, 7 minus, oh goodness, I don't know. Oh, here, I have a rubric. I apologize. I should have looked at their rubric. They have 9π/4 minus 4. There we go. Sorry. Like, ooh, that's going to be a little bit tricky there. Oh yeah, because then that'd be 2 plus 9, which is 11. 7 minus 11 is -4. So -4 plus 9π/4 if you wanted to simplify it. But you don't have to. Okay? 3 points. One came from being able to somehow recognize that the integral from -6 to 5 of f of x dx is equal to the sum of its two parts, -6 to -2 and -2 to 5. So using that relationship there somehow. And it's possible you wrote it different and you would still get that point. So again, if you weren't sure, like I wrote it this way, do I still get that point? Send me a picture, more than happy to check it for you. It's using that relationship. The second point came from just the -2 to 5 evaluation. So all of this stuff in here, which was all the different pieces of the area. And then one came from your answer, recognizing again that if you did make an error, as long as you haven't oversimplified the problem, again, I can check for you, but if you did make an error, you could still get your answer point, depending on what your error is. Okay? Okay. B, evaluate the integral from 3 to 5 of 2 times f prime of x plus 4. Okay, so the integral of 2f prime is 2f, 2 is a coefficient, integral of f prime is f, integral of 4 is 4x. Plugging in the upper, we have 2 times f of 5 plus 4 times 5, which is 20, minus plugging in the lower, 2f of 3 plus 4 times 3, which is 12. And so then we just need to figure out what f of 5 and f of 3 are in this particular case. Okay, so we have a graph of f. We can see what f of 5 is. F of 5 is 0 here. So this is 2 times 0 plus 20. And f of 3, they told us. F of 3 is 3 minus root 5. And then call it good. If you did simplify this, this would be 20 minus 12, which is 8, minus 6, which is 2 plus 2 root 5. 2 plus 2 root 5. Okay? This one was also worth this one was worth 2 points, not 3. So it was worth 2 points. 1 for your fundamental theorem of calculus use in here, and 1 for your answer. Okay. Okay, part C, we have the function g is given by that. Several videos ago, I think it was on the FF prime, F double prime graph video, although I've said it a couple times since, I made the recommendation that the minute you see a relationship like this, take a moment and take its derivative. You don't always end up using it, but a lot of the time you will. Okay? So second fundamental theorem of calculus, plugging in the upper, times the derivative of the upper, minus plugging in the lower, times the derivative of the lower. Okay? And you just earned yourself a point. Okay? Even if you have no idea how to use that, one of the points this year did come from finding that the first derivative equals f of x, or the first derivative of g equals f of x. So again, I highly recommend when you see that relationship, especially in the context of an FF prime, F double prime graph problem, take a moment and take the second fundamental theorem of calculus. Sometimes you snag a point. Okay, the reason we want to do that is this. We're trying to find absolute maximum values of g on -2 to 5. Well, how do you find absolute maximums? Okay, this comes out of 3.1. We take our derivative, which is our g prime, and we set it equal to 0. Okay, so where does g prime or f equal 0? Well, here's f. f equals 0 at -1, 0.5, and 5. And then you take those values that you found, all those zeros, and your endpoints, which in this case are -2 and 5, so we're definitely using 5. It's both a 0 and an endpoint. We're also going to do -2 though. And we plug them into our original function, -2, 0.5, sorry, -1, and 5. And actually, just for the record, in this particular problem, there is one of these values you don't actually have to assess. An absolute maximum would not be at negative or at 0.5 here, because 0.5 is a relative minimum. Right? My first derivative graph changed from negative to positive at that point, so it's a relative minimum. It can't be a relative minimum, but the absolute maximum. Those are counterintuitive, so you don't actually have to evaluate that one, but I'm going to. You also, by the way, earned a point for identifying that -1 is one of the possible locations. So I mentioned a couple videos ago that when I see absolute extrema within FRQs, I always take the derivative, set it equal to 0, try to find those zeros, and then I stop working through the problem at that point. I move on, I keep going, because a lot of times the rest of this work is only 1, maybe 2 points. A lot of times. Again, not always, but a lot of times. And it's a lot of work for only 1 point, and I would hate to miss out on other potentially easier or faster points to grab. And so I only come back to this either when I finished all the other parts, or when I maybe hit a part that's a little bit weird. I'm like, you know what, I'm going to go back and go ahead and finish that absolute extrema, and then if I have time, I'll do the weird part, right? But I skip it and move on initially. Okay, in the video here, I'm going to go ahead and solve this one out. So plugging -2 into our g function here, which is the integral from -2 to -2, which is 0. Our 0.5 integral from -2 to 0.5, which we'll do in a bit, -2 to 1, -1, sorry, which we'll do in a bit, and -2 to 5, which we actually did this one above, so I'm going to go ahead and start here and write this one down. -2 to 5 we found up here. It was all of this work back here. And so I'm going to go ahead and write that down. We have our 1/2 times 1 times 1 plus -1/2 times 3/2 times 1 plus 1/2 times 3/2 times 3 plus 9 minus 9 pi over 4. And because you are going to have to evaluate whether this is an absolute max or an absolute min, trying to find out if it's the absolute max here, you might at this point simplify it or not. Again, it's your choice. It just depends on how comfortable you are making that assessment. But this one would simplify to 11 9 pi over 4, right? Because there's the 2 here plus 9, which is 11 minus 9 pi over 4. Okay? And then coming back up here, so -2 to -1 is just this little itty bitty triangle here. 1/2 base of 1, height of 1. Okay, so we, again, may or may not have evaluated 0.5. I will, in case you identified 0.5 as a possibility, but again, you didn't have to. So 0.5 is this triangle, 1/2 base of 1, height of 1, and this one, the -1/2 base of 1.5, height of 1. So 1/2 base of 1, height of 1, and the triangle below the x-axis, -1/2 base of 1.5, height of 1, which is 1/2 minus 3/4, which is -1/4, confirming why it's not the absolute maximum, right? All of our values actually end up being bigger than that one. It's our absolute minimum in this particular case. Okay? But we want the absolute maximum, so what's our absolute maximum? Well, 0 is not, 1/2 is not. We have 11 minus 9 pi over 4, that is. So absolute maximum is our g of 5 here. Which, yes, this is a non-calculator one, so you would be expected to know what that value was. I should say you would at least be expected to know that that value was bigger than 0 1/2 by doing some sort of approximation, right? Pi is around 3. Get just a rough approximation, so we're looking at 27 over 4, which is around 7, and 11 minus 7 is 4, right? So this is pretty significantly larger than both 1/2 and 0. Okay, and that was your third point, by the way, was your answer with justification. Justification means your work, and so your work here does count. I don't need to explain. Explain means words, justify means work or words, whichever one is most applicable and most thorough. Okay? And then part D was our last point for this particular problem. It's one that I know some people look at and kind of our gut instinct is to go, oh, it's probably going to be L'Hopital's. But it actually ended up just being a straight limit one, which is plugging in our 1 to our top and bottom. So we have 10 to the 1 minus 3 times f prime of 1, f of 1 minus arc tangent of 1. And then remember, you don't have to simplify anything. However, f prime of 1 and f of 1 are not unsimplified, they're unevaluated. So you do need to be able to figure out what f prime of 1 and f of 1 are. But like the 10 to the first or the times 3, like all those other pieces, they don't actually have to be simplified, although I will walk through that so we can check it for those who did simplify. Although again, one more time for this video, I would not simplify. Okay, f prime of 1, the derivative at 1. Okay, well here's 1, this line here is up 2 over 1, up 2 over 1 for a slope, and so my slope up 2 over 1 is 2. F of 1 at x equals 1, my f of 1 is 1. And then, oops, let's go ahead and evaluate arc tangent of 1 for those who did that. What angle of measure gives me a tangent of 1? That would be pi over 4. Which again, I honestly, I wouldn't even do the raised to the 1 power, the arc tangent of 1. I'd leave it alone myself, but you could evaluate it. And then 10 minus 6 is 4. 1 minus pi over 4. Go ahead and leave it there. And I suppose you could take it one step further and maybe get rid of the extra denominator, but there's not really any reason to do any of that, really. I would leave it more unsimplified for sure. Okay, especially because it was only worth 1 point. Okay, those are your 15 minutes. Let me know if you have any questions.